What is up, Algebra 2? Topic number 7 for your midterm, last one. Factor, solve, graph, polynomials, the whole shebang. We are going to cover 2 examples. The first one, we are going to review factoring by grouping. You will have to do it on your midterm. And then we will do one graphing problem. So let us start with factoring by grouping. We are going to factor by grouping when there are 1, 2, 3, 4 terms. 4 terms means we need to factor by grouping. So we're going to write our problem. X to the third plus 5x squared. This is our first 2 terms, so this is group 1. Group 2, negative 4x minus 20. This is group 2. Group 1, group 2. If you ever have an x standing all by himself, give him a friend and put in that invisible 1. Now our goal is to take out a GCF from both of these. So step 1, grouped. Step 2, factor out the greatest common factor from both pairs. So if we look at this first one, 1 can only be made by doing 1 times 1. 5 can only be made by doing 1 times 5. Our first term has 3 x's. 1, 2, 3. Our second one has 2. 1, 2. If I'm looking for my greatest common factor, the biggest number they have in common is 1. And I can take away 2 x's from both terms. After doing this, I'm going to take my greatest common factor, which is 1xx, or 1x squared, and I'm going to put it out front. Leaving me with 1 divided by 1 is 1. If you look, it's just your numbers that aren't circled. 1x. And 5. Positive 5. Now we're going to do the exact same thing for the second one. 4. 1 times 2, or 1 times 4, or 2 times 2. For 20, we have 1 times 20, 2 times 10, and 4 times 5. Our 4 has an x. The biggest number they have in common is 4. And I can't take any x's away because the 20 doesn't have any to give. Now, this is a very, very tricky one, and that is because of this pesky negative in front. Our goal is, when we divide by our GCF, we need whatever's left over to look exactly like our first group. If I divide by 4, I'd be left with negative 1. And I need it to be positive 1. The trick here is I'm not going to divide by positive 4. I'm going to divide by negative 4. When I divide negative 4 by 4, I'm left with 1x. When I divide negative 20 by 4, I'm left with positive 5. And now you can see my groups match. So all I have left to do is to write my final answer. I'm going to take my factor that is exactly the same, and I'm going to factor it out. So my first factor is 1x plus 5. Okay, so I've used both of these factors. All that's left is 1x squared minus 4. And we are all done factoring by grouping. Step 1. Step 2, step 3, good work. Okay, make sure it's down. We're on to the next one. Okay, so the last one, we are going to use our end behavior cheat sheet. Make sure you know this. Make sure you know your shapes. Make sure you know when they're pointing up, down, opposites, how many squiggles, humps, hills, roller coasters they have. Okay, we are going to be using this in our last problem. If you don't have this, Tokar's probably got some copies next to the pencil sharpener. Okay, take a second and copy this problem down and a little sketch of a coordinate plane. All right, you got it copied down. Let's graph a polynomial. So here's our polynomial. We are given its standard form, and we're given its factored form. So these are the same polynomials. One is the raw polynomial. The other one is its factored form. Now, the standard form is going to help us know what shape it has. The factored form is going to tell us where it crosses the x-axis. So here's our x-axis. We need to figure out what points are we going to mark up on this coordinate plane. Okay, in order to do that, I need to set each of my factors equal to 0. So I have x equals 0. I have negative x plus 6 equals 0. And I have 2x minus 1 equals 0. So hopefully we're getting better at solving an equation. I draw my squiggles down my equal signs. And I'm going to solve each one of these all by itself. The first one, we already have x equals a number. So x equals 0. We're going to plot that on our coordinate plane. X equals 0, right in the middle. Next one, I need x by itself. The only way to do it is moving this positive 6. Since we're adding 6 on the left, I can get rid of it by subtracting 6 on both sides. Okay, so that gets rid of my 6. I'm left with negative x equals 0 minus 6, which is negative 6. Now I'm going to put my little invisible 1 here. Because x isn't by itself yet. It still has this negative 1 out in front. To get rid of a negative 1, when it's touching the x, these are being multiplied. So the opposite would be to divide both sides by negative 1. When I divide negative 1 by 1, I get 1, leaving me with just the x. And negative 6 divided by negative 1 is positive 6. So here's my next solution that I can plot on my graph. Positive 6. 1, 2, 3, 4, 5, 6. Another point. Okay, one more solution to go. I need x by itself, so I got to move this 1. It's a minus 1, so I add 1, the opposite to both sides. I'm left with 2x equals 0 plus 1. And like we did before, this is 2 times x. These are being multiplied, so I need to divide them. 2 divided by 2 is 1. And here, x equals either 0.5, or I like to just leave it as my fraction, 1/2. So I'm going to go over to my graph, and I'm going to plot 1/2, which is right in between here. Now, my points are really close together, but that's okay. Now I need to figure out what this graph looks like. I have 3 points, and I know my graph will go through these points, but I don't know what shape it has. And that all comes down to what this first term is in my polynomial standard form. Here, I know that my degree, my largest exponent, is 3, which is an odd number. And I know that my leading number, my number all the way in the front, my lead, is negative 2. And this is a negative number. So I know that I have an odd negative function. So if I go back and look, odd negative function would look like this. And what I'm really looking for is where are my arrows going on both sides? I'm going up on the left and down on the right. So I'm going to draw an up arrow on the left above my left point and a down arrow on the right below my second point. Now, I know that this is a degree 3. It's a cubic function. Degree 3 look like this. So I'm going to have a squiggle and it crosses 3 times. So starting from the top, I'm going to come down through my point, turn around. That was terrible. Down through my point, turn around, back to the bottom. And here is my graph of my polynomial function. Make sure you have this. Make sure you have your sketch. This will come in handy. You have finished all 7 topics. Good work. You did it. Now it is time to practice the problems that go with this and to review all of these topics, because you will see a little sprinkle of each on your final. Good work. Tokar is out of here. Good luck on your finals. Quack, 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 quack.